Because when we're interested in factoring a number into primes, we only need to look for factors that are prime, it's helpful to be able to recognize when some of our, small, easy to remember prime numbers are factors of the number we're looking at. And fortunately, for most of the small prime numbers, there are easy ways to tell. I'm also going to mention a couple of numbers that are not prime because they're kind of included in these rules. Multiples of 2 are very, very common, right? In fact, every other number is a multiple of 2. 2, 4, 6, 8. They're so common, they have their own name. They're called even numbers. And we can recognize them just by looking at their last digit, their digit in the ones place, is one of the even digits, 0, 2, 4, 6, and 8. Notice, 0, 2, 4, 6, and 8 are even one-digit numbers. Then 10 has ones digit 0, 12 has a 2, 14 has a 4, 16 has a 6, 18 has an 8. What will the next even number be? Well, 20, ones digit 0, and so on. As an aside, numbers that are not even are called odd. You should also be familiar with that term. The next small prime whose multiples are easy to spot is 5. They have a 0 or a 5 in their last digit. Notice, the first few multiples of 5 are 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, and so on. So, multiples of 2 are easy to spot, multiples of 5 are easy to spot. Why? Well, 2 and 5 are nice like this because they're both factors of 10, which is what the number system is based on. 10 is also nice. Multiples of 10 all have the digit 0 in the ones place. Now, of course, 10 is not prime. 10 is 5 times 2. So why do I mention this? Because dividing by 10 is super easy. Right? If it's a multiple of 10, its last digit is a 0. To divide by 10, we knock the 0 off. So spotting multiples of 10 is going to be super convenient when we're trying to factor things. All right, that's 2 and 5. What other small primes have we got? Well, we've got 3. Multiples of 3 have this really cool property. A number is a multiple of 3 if, when we add all of its digits up, we get another multiple of 3. What? Let's see an example. Let's say we have the number 2,856 and we want to know if it's a multiple of 3. Well, 2 plus 8 plus 5 plus 6. 2 and 8 is 10. 10 and 5 is 15. 15 and 6 is 21. 21 is a multiple of 3. So this number must be also. Don't believe me? Let's check. 3 doesn't go into 2, but it goes into 28 9 times. Three goes into 15 5 times, and 3 goes into 6 twice. So yes, in fact, when we divide 2,856 by 3, we have no remainder. 2,856 really is a multiple of 3. 3 really is a factor of 2,856. This is kind of a weird property. Even weirder, 9 shares it. Again, 9 isn't a prime, so this isn't strictly necessary. But it's kind of a cool property nonetheless. And in fact, if we were memorizing our multiplication table, we could use this to really help us keep track of what the multiples of 9 are. Again, why? This is a kind of a quill property, and it has to do with the fact that 9 is 1 less than 10, the number that our number system is based on. Wait a minute, 9 has a quill property because it's 1 less than 10. What about the number that's 1 more than 10? Well, it's not quite as nice, but it's still pretty cool. A multiple of 11 that's less than 100 is the same digit repeated twice. So we have 11, 22, 33, 44, and so on. Right, these numbers are really distinctive, easy to spot, easy to divide by 11. Right, 66 is 11 times 6, for example. After that, well, 110 is pretty easy. That's 11 times 10. 11 times 11 is a little bit trickier because when we multiply, there's some addition that goes on. So they're a little harder to spot after that. But these 9 will be very useful to us. What about 7? Yeah, 7's a pain. But there are really only a few multiples of 7 that we don't catch this way. 7 times 7 is 49, and 7 times 13 is 91. Why do I mention those two specifically? Other than those two, these rules are enough to factor every composite number less than 100. So if it's not a multiple of 2, not a multiple of 5, not a multiple of 3, not a multiple of 11, and not 49 or 91, and it's under 100, then it's prime. For example, 89 is prime. Its last digit is 9, so it's not a multiple of 2 or 5. 8 plus 9 is 17. 17 is not a multiple of 3, so 89 isn't a multiple of 3. 89's two digits are different, so it's not a multiple of 11. It's not 49 or 91, and it's less than 100. We know it's prime without having to go through and divide it by every number. And that's really nice. If we want to factor, say, the number 78 into primes, well, 78 is a multiple of 2. So 2 can be one factor. To figure out the other one, we'll divide. 2 goes into 7 3 times. 2 goes into 18 9 times. No remainder. So 2 and 39 are factors. 2 is prime. 39, not a multiple of 2 or 5. 3 plus 9 is 12. So 39 is a multiple of 3. 3 goes into 3 one time. 3 goes into 9 3 times. No remainder. So 39 is 3 times 13. 3 we know is prime. 13, not a multiple of 2, not a multiple of 5. 1 plus 3 is 4, so not a multiple of 3. Not a multiple of 11. Not 49 or 91, so it's also prime. The prime factorization of 78 is 2 times 3 times 13.